everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. In today's course, we are going to discuss about Introduction to Data Structures through Python. Let us see the overview of the course, why to study these data structures using Python, and what are the prerequisites for this course, and what are the books and references you need to look into the data structures, and what is the syllabus we are going to cover under this course, and what are the real-time examples that will cover for data structures, and what are the course outcomes we have. All these concepts we are going to discuss under this today's session. Why to study data structures? As we know, data structures are the way of organizing and storing data so that it can be used efficiently. When the data is not given in a proper format, the data is not in the organized way. First, we need to organize the data, and then that will be used for storing. And when you are going to store the data in an organized way, that will be used efficiently. How efficiently we are going to use it? Let us see the next one. Studying data structures helps programmers handle data in a structured and logical manner. Not only placing the data in a particular format, we are going to logically how they are going to be connected. That one also we are going to study under these data structures. And instead of writing complex code again and again, data structures allow easy access, and we can do modifications and storage of data that can be done easily. Right? Let us see how we are going to access the data easily and how we can modify the data. All these things we are going to study under this course. They help in improving program speed and reducing the memory usage also. When you are going to have the data structure is going to be placed in an organized way, that will be given for accessing easily, modifying easily. At the same time, we can store the data easily. In the simple words, we can say data structure make programs faster, cleaner, and more efficient. More efficient means how efficiently we are going to get the data and how efficiently we are going to use the data. And what are the prerequisites that we need for this course? Basic understanding of computer programming terminologies. This is a basic knowledge that we need to have. What is the computer programming terminologies we are going to use? That is the basic one, where that is required for you as the prerequisite. And basic understanding of any programming language is one more plus point for you. Like you may be already studied about the C language. That may be giving you a plus point for knowing about the programming languages. And what are the books you can refer for these data structures using Python? One is the Data Structure and Algorithms Using Python, Rands D. Nasi, John Wiley and Sons. This is one book which you can refer, and the other book is Data Structures and Algorithmic Thinking with the Python. This is another book where you can refer for writing many programs, so many examples that you can find it in these data structures using algorithmic thinking and with the Python. And this is one more book that is given by Narasimha Karumanchi, and that is he is a person of IIT Bombay. And what is the syllabus we are going to cover under these data structures using Python? The first unit that is going to cover is the data structures using linked list. We are going to see about what is the basic terminology we are going to use in data structures, and what are the classifications under the data structures, and what are the different operations we are going to perform, and what are the abstract data types, and what is the difference between the primary data type and abstract data type. These differences we are going to look into. And at the same time, we are going to discuss about the linked list concept. Under linked list concepts, we come across 3 different types of linked list. Those we are going to discuss its types and its operations also. What is that? Single linked list operations. What are the operations we are going to see is insertion and deletion. With that, we will be discussing about another linked list, that is circular linked list, where the same operations are going to be performed, that is insertion and deletion will be performed on circular single linked list, and in the same way double linked list operations also. The same insertion and deletion operations we are going to perform on doubly linked list. And while coming to the second unit, as we are going to cover what is stack and queue. Stack and queue are other classification of data structures where we are going to perform what are the different operations that will be applicable for stack, that is like push, pop, pick, what is the top element that was present in stack. All those details we are going to discuss under the stack. Not only discussing about the stack concept, we will be discussing about on implementing array and linked list implementation using Python also. And when you are going to see about the applications of stack, here we come across infix to postfix conversion and postfix expression evaluation also. And these are some of the applications where we are going to study under the stack, where we will be seeing about what is the algorithm that will be applicable for infix to postfix conversion, and at the same time, when you have given an expression, how that will be converted into postfix expression also. That one also we are going to discuss. And not only that, about the stacks, we are going to discuss about QADT. That means what are the different operations we are going to perform on queue. With that, again, we are going to implement what is queue array implementation and linked list implementation also. With the queues, we are going to discuss one more concept. What is the disadvantage that we come across queues that will be overcome with the circular queues. That concepts will be covered with what is a circular queue and how we are going to perform the insertion and deletion operations. And there also we are going to discuss what is the array and linked list implementation. This is about your second unit where we are going to cover. And coming to the third unit, here we will be discussing about completely the advanced things, that is about the trees. Here we will be discussing what is the introduction of tree, what is the different terminologies we are going to see under trees, and what are the different types of trees we will have, and we will be seeing about what is a binary tree from a general tree. When you are going to represent the normal tree representation, as we know that we are going to represent normally, that is in a normal manual representation. First, you are going to have the tree will be like this, right? And you will be having root at the bottom, and you will be having the branches, leaves and all. And in computer science language, we are going to represent the tree in the reverse order. We are going to have the root on the top, and then related to that, we are going to have the branches and all these things to be represented. Branches, nodes, all these are going to be covered. And this is the how where you are going to create a binary tree from a general tree. Normal representation is this. And in computer science, how we are going to represent a binary tree. And not only that, how we are going to traverse through the binary tree. That means from one node to other node, how we are going to move. That one we are going to study. And here we are going to have different traversing techniques are present. That is, we are going to have in-order traversal, pre-order traversal and post-order traversal. These concepts also we are going to cover under traversing techniques. And not only binary trees, we will be looking into the other concept, that is binary search trees, BST, and what are the different operations we are going to perform on binary search trees. And those are, we are going to perform searching, insertion and deletion. These are the different operations we are going to perform. Not only performing the operations, we are going to see the implementation of binary search trees also. That means the implementation part also we are going to cover. And we will be seeing about what are BST applications, that is binary search tree applications, where we are going to use. That concept we are going to cover. And we will be seeing about the advanced trees called AVL trees, and we have the red-black trees and split trees. These concepts we are going to cover, and with that we are going to have another concept called multi-way search trees. These are nothing but B trees, and we are going to look into how B trees will be represented, And the same operations like how we are going to construct a B tree and how we are going to perform the insertion and deletion operations under B trees. This is the third unit where we are going to cover. And coming to the fourth unit, graphs and sorting techniques. This is the fourth unit where we have. Here we'll be discussing about how we are going to represent a graph and what is the different terminologies we are going to use under graphs and what are the different graph traversal techniques. Basically, we have two graph traversal techniques we are going to discuss, that is BFS, that is breadth first search, and the other one is DFS, depth first search. And we are going to see the implementation of graph ADT, that is what are the different operations we are going to perform on BFS and DFS, and what are the applications of graphs also we are going to look into. And with that, we are going to look into the sorting techniques as we have been studied in your programming for problem solving about other sorting techniques, like you may be studied about the bubble sort, insertion sort, and selection sort. These sortings you may be already studied. With that, the advanced sorting techniques, there may be some time complexity issues with this. That's why we are moving on to the other sorting techniques, that is merge sort, quick sort, and heap sort. These are going to reduce the time complexity. We are going to discuss about each of these concepts under the unit 4. And we will be seeing about the comparison of sorting methods also. That means what is the time complexity and space complexity that will be applicable for all these, and which will be the best sorting algorithm that can be applicable for any of the application. And the last unit where we are going to cover is about hashing and collision. And here we are going to discuss about what are the hash tables. Mainly hashing will be used for searching, right? When you want to search a particular element, that in that particular case we are going to have some searching techniques out there. In that, one of the concept where we are going to use is hashing. Here we'll be seeing about what is the introduction to hashing and what are the different hash tables we are going to use and what are the different hash functions we are going to have. Here we are going to have different hash functions that we are going to discuss under this fifth unit. Is division method is one, and you have multiplication method, mid square method, and folding method. All these are different hash functions where we are going to look into that different methods of hash functions and which will be applicable for which of the application. That one also we are going to cover. And not only that, we are going to have other methods called collision methods. When you are going to do for some searching, there we are coming up under the concept of collision resolution by open addressing. This will be done by using collision resolution by chaining also, right? When you are going to insert some element into your hash table, at that time the same place has been occupied by the other element. In that particular case, we'll be going for this collision resolution techniques, right? This will be covered under this collision techniques, and with that we'll be seeing some basic concepts of files and their organization. What is file and how we are going to store the data into the files, and what is the hierarchy we are going to maintain for files, and what are the different file attributes we are going to use, and what is the difference between a text file and binary file. Text file means it will be in the form of some sentences, right? When we are going to see about the binary files, binary file will be in the form of ones and zeros. We'll be looking into how we are going to represent the text files and binary files, how difficult you are going to face with the text files and binary files. The differences also we are going to look into. Only the theoretical part we are going to discuss here. And basic file operations. That means when you are how you are going to open a file, how you are going to close a file, all these things. And when you are going to open a file, how you are going to open the file in different modes of operation, like read mode, write mode, append mode. All these concepts we are going to discuss under this files concepts. This is the fifth unit where we are going to cover. And coming to the real-time applications of these data structures, basically we will be discussing about ticket booking system, and another one is music player. This is one more application where you can look into, and web browser is one more real-time example, and line of queue is another example. And then we are going to see about the Google Maps. All these are the real-time applications where we are going to use in our data structures. Let us look into one of each. Ticket booking system. As you know that we are going for any movies or we are going for any bus ticket, right? At that particular time, we are going to use this ticket booking system. And when you can see here you will be representing rows and columns. This is the concept of arrays where you have been already studied in your PPS, right? Arrays concept, this is a two-dimensional array where it is representing. When I want to book a ticket of this particular row and column, what it is representing? It is representing 6 and 3. That is, in 6th row, 3rd column, I want to book a ticket. This is one of the real-time application where the array concept is going to show. And coming to the other one, music player. As you have been using Spotify or some other music players, you will be having a list of songs that has been playing, right? If I want to play a particular song in a sequence, it is going to play that songs. This comes under the concept of linked list. That means you can play the songs in a sequence order or in a random order. Any way we can play. This will be a connection from one song to another song. When you have song 1, song 2, song 3, I want to listen these songs continuously, then we are going to use the concept of linked list. This is one of the real-time example where we are seeing that one in a daily life. And the third one is web browser. You may be opening different web URLs. Like as I told you, we are going to have Google is one web browser in URL you are going to open. And after that, you have been opened Facebook. Then you have been opened LinkedIn. Right? If you have been opening all these URLs one after the another, how this is going to be maintained in stack? When you have been opened in the same order, when you have opened first Google Meets, it will be stored into the stack as the top element. Then after that, it will be moving on to if I have opened Facebook, then it is going to be stored on the top of the Google. Then if you have been opened LinkedIn, that will be on top of this one. Like this way, when whatever the new URL you are opening, that will be placed on the top of it. When I want to open Facebook means, then automatically my top will be moving to the Facebook, right? Now it is pointing to this. Now this is not going to be pointed. Now this will be pointing as the top. According to this particular URL you can able to see. Suppose I want to open Google, then my cursor, that is my pointer, will be moving, that is top will be moving to this Google. Now according to this, now I can able to see Google. Like this way, the web browser will be storing whatever the URLs you have been opening, that has been stored into stack in this particular order. Whatever the new URL you have been opened, that is going to be placed on the top. This is one of the example for web browser. And the next one is queue. Wherever you are going to find this in ATMs, you'll be finding it in ATMs or any bank or any transport. For boarding the bus, they may be using the queue lines, or in temples also you can able to see, right? In all these places, you are going to look into this queue concept. And the other one where you are going to see this one is graphs. Graphs is one more real-time example. Many of you people have been using this Google Maps, right? From one location to source to destination if you want to reach. You may be looking into some Rapido, or you may be using some Ola. In all these places, we are going to use this Google Maps. From one location to other location, if you want to move, then we are going to use this graphs concept only. That means the source and destination will be selected. Based on that, it will be showing you the shortest path. You'll be selecting the shortest path, and based on that, you will be moving into that particular location. This is one more real-time example. This is also comes under the concept of data structures. Then coming to the course outcomes. At the end of the course, what the student is going to learn. As we have discussed about all 5 units, the unit 1 where we have seen about the linked list concept. At the end of the course, the student can implement the linked list data structures using abstract data types to perform various operations. What are the operations? Like you may be performing insertion, deletion, searching. All these operations here can perform by using the linked list. We have seen about the linked list also. We have 3 different types of linked list. By using that, he can implement all these operations. And in the second unit, we have discussed about stacks and queues, right? And here also implement stacks and queue by using abstract data types for solving applications on linear data. When you are going to see about the classification of data structures, these stacks and queues comes under the linear data structure, where the student can able to implement these stacks and queues operations by using abstract data types. And the third one, choose an appropriate nonlinear data structure for representing and solving real-world problems. Nonlinear means that comes under trees and graphs. These two are nonlinear data structures where we can use is appropriate. We can select any nonlinear data structure based on the given data. We can apply either trees concept or the graphs concepts. And compare different sorting techniques based on time complexity, space complexity. That is how much time it is taking to sort a particular given elements. That in that particular case, we are going to use the time complexity and space complexity. Right? Here we are going to discuss about 3 different sorting techniques as we have discussed. Merge sort, quick sort and deep sort. Among these 3, what is the time complexity and space complexity it is going to occupy, and how efficiently these algorithms are used for solving a given problem. This one also the student can able to do at the end of the course. And the last one, the appropriate hashing techniques will be used as we are going to have different hashing techniques, hash functions also there. We are going to use the division method, multiplication method and mid-square method and folding method. These are different hashing techniques we have to find the mapping keys to hash tables and indices. These things based on this which method that will be useful for a particular data that has been given, that can be selected by the student. At the end of the course, the student can able to do all these things. And coming to the summary, at the end of the course, whatever we have been studied, whatever we have seen up to now, why we need to study the data structures concept, this is one thing. And what are the prerequisites that we require for studying the data structures course? And what are the books and references? I have given 2 books. You can refer those 2 books for studying these data structures using Python subject. And what is the syllabus we have been covering in all 5 units? One is linked list, another one is stacks and queues, and the other one we are going to discuss about trees, and other one we are going to discuss about graphs, and the last one we have hashing techniques. These are the different 5 units we are going to cover in this syllabus. And we have seen about the real-time applications in the data structures about all these 5 concepts. And what are the course outcomes at the end of the course, what the student is going to learn. That one also we have seen. Thank you. I hope I have understood the concept, and further we will be looking into all the concepts with implementation of data structures using Python. Thank you.